Hello, so let's move to our first section or first topic, which we are going to start now. So the first point is the key input. Okay, so in whenever we deal with any of the embedded system, we definitely require a key input. Okay, or there could be a possibility that we will directly connect the key input to the microcontroller. Okay, so how we can do that? Okay, so it is very easy. Okay, and how we will interface that we are going to see now. So if let's consider any microcontroller and we have a different pins over the microcontroller. Let's say we have a port 0. Okay, so we will consider the port 0, any of the port we can consider, and there we can connect the key. Okay, so as shown in the diagram, you can see over here that this is the microcontroller and this is the pin. Let's consider the pin named as P70 or probably the port 0 pin number 7. Okay, depending on the different controller, we have the different name of the port pin. Okay, and here we will be connecting the keys. You can see this is the key symbol, and this is in the off situation or off position, and here we will connect basically a high voltage. So in case of switch being is open or being off, in that case you can see the high voltage will be transferred to the port pin directly. Okay, so we can consider that whenever the key is off, we will get a high voltage. Okay, now let's consider a case where switch is being closed. Okay, so we are basically providing a ground to that line, and the overall voltage will drop at this resistor. Okay, so the calculation will happen how exactly we need to choose the resistor value and other stuff. So, but we are not going to cover on those part. So we can just see that whenever the um, key is in off position, we are getting a high voltage, and whenever the um, key is being pressed, we are going to get a low voltage. So how we will detect the high voltage and low voltage? Okay, so to understand that, I think you all need to know the basic things of the, as I mentioned, that the binary and hexadecimal values. Okay, how exactly it will work. So I think you already covered those things as a part of your um, bachelor degree course or somewhere else. So here we will be considering, let's say, port pin 0, 1, 2, 3, 4, 5, 6, 7. So we need to see, look at the directly this pin whether it is 1 or 0, and based on that we can detect what exactly is the position of the switch. Okay, so before doing that directly, we will provide a high voltage, or we will just consider this pin as an input voltage. How we can do that? That we can just load a high value over that, and whenever the key is being pressed, we will detect the low value. So using that, we can detect the key is being pressed or not. Okay, so let's move to the next slide, and here we can see. So if it is high and low detection is very easy, we can say that there is only one line or probably one if condition is required to detect that things, and it is very simple thing. Now if it is that simple, then why do we need any other things? Okay, so there is one more part which we need to consider along with the switch condition, which is 0 or 1. So which is a key debouncing delay. So what exactly will happen whenever we press a key? There are certain amount of vibration will happen. Probably you can see over here that will be the on off, something like that will happen. So whenever we press the key, we will get certain volt signal like this, and whenever we release, we'll probably get the signal like this as well. So this will probably trigger like multiple high to low and low to high transition. And to avoid that, what we can do, we can provide a delay depending on the, like, let's say 5 to 10 millisecond, or depending on the how exactly we are interfacing or which kind of key we are interfacing, and that based on that we can select the this delay time. So once we detect the low transition, high to low transition, and then to confirm that we will use the delay. So once we detect that low value, and then we'll give a delay of 5 say or 10 millisecond, and again at this stage we will confirm whether that is still being zero or not. Okay, and again here, like, let's say we'll confirm the high, and again at the later point we'll confirm that whether it is again at the high value or not. Okay, so this way we need to use, and basically this is required because there could be a case where there is a small spike because of certain noise, and if we haven't this you if we haven't used this debouncing delay, and there could be a probability of false trigger or false detection of the key pressed condition. Okay, so to avoid that we need to use this, and we can develop a small software delay directly using a timer directly of 5 or 10 millisecond, and we can avoid this situation. So mm, so that we talk about the debouncing delay, and let's move to the next point, which is we have now is a 4 cross 4 matrix keypad. So to consider the 4 cross 4 matrix keypad, we consider here an example where we have a key 1 to 9 and 0, and there could be some extra keys which is A, B, C, D, star and hash. So you can see that is being considered this kind of keypad over here, and which we probably like to interface with our microcontroller. So the main purpose of the matrix keypad is to facilitate more number of pins or more number of keys using a less number of lines. So think of the possibility where we will not use the this 4 cross 4 matrix keypad. In that case we need separate lines for the each key. So let's say if we have a 4 cross 20 16 keys, and then we will require the 16 keys separately or 16 port lines separately to detect the key press condition and key release condition. Okay, so instead of that wasting of 16 port pins, we can have the same situation using 8 keys. Okay, so we that's why we come up with the 4 cross 4, which is 8. So here we consider the x1, x2, x3 and x4, that is an we consider as an let's say you can consider as a row, and y1, y2, y3 as an column. Okay, so we require this 4 plus 4, it is 8 lines to have 16 possible key values. Okay, so as we understood that we can connect in this way, we need to connect, let's say the x will be the x1, x2, x3 as in row, and y1, y2, y3 as in column. And how we will detect the x1 key is being pressed? So we need to have a combination of different things, let's say x1, y1, x1, y2, x1, y3, x1, y4. Okay, so this way we can detect the 4 keys, and similar way let's say the different combination will give us the different key values. Okay, so let's see how exactly and what exactly we need to do. So to configure the here you have it is mentioned that to configure the x1, x2, x3, x4 as an output, because we need to what exactly we will do over here is we will configure that x1, x2, x3 and x4 as an output, and y1, y2, y3 and y4 as an input. Okay, so whatever the value we will transmit or output over the x1, if we are getting the same value over the y1, we will get the same value. So if the key is being pressed, okay, then let's say it is 0 over here, and then we will be getting a 0 over here as well. Okay, so that is the way we are going to see and detect the key value. So for the key 1 we have a combination of x1 and y1. So let's see the what exactly we'll do over here. So to configure the x1, x2, x3, x4 as an output, we will configure this pin as a low, means 0, we will output the 0. And to detect the switch position key and like key pressed or released, we need to make the y1, y2, y3, y4 as an high or an input, because we will be getting those values. So we will configure that as an high. So basically we will load the value high on those lines. So if we don't do that, then we will probably not able to detect that pre-release key release condition and press the condition. That's why we need to do that. Okay, so we need to, let's say if we're going to use the same port for the this thing, then the we will load the value f, which is old ones, 4-bit ones, and 0, which is output. Okay, so x1, x2, x3, x4 as in like these lines, and these are the input, so that's why those are the one lines. So these are the y1, y1, y2, y3, y4, x1, x2, x3, x4. Like way we need to output the port x as an f0. Okay, so if you have a doubt that how what exactly is mean by that, then probably you do not understand the hexadecimal value. Okay, so that's why the 0x f0 is the representation of the hexadecimal value. So if you don't do 0x, then it means it is a decimal value, but here 0x all itself represent the hexadecimal value. And whenever we deal with the microcontroller, it is always better to write the values in hexadecimal, so which by which we will be able to understand the things very clearly and better. Otherwise we need to always convert the decimal value to hexadecimal, and then we will get the bit, whether it is a 0 or 1, we will get the bit values. So it is easy to interpret the value in hexadecimal. That's why we always write the value in hexadecimal. Okay, so let's move to the next point. So let's consider the case where so here we'll go to the first case where x1 is being 0, y x2, x3, x4 are all being 1. Okay, so, and then we will scan the y1, y2, y3, and y4. So we are making the x1 as in 0, and all the other bits are 1. So and then if that case we are getting y1 as in 0, that means x1 is being transmitted to y1, and that itself indicate that switch 1 is being pressed. So here also let's say you can see the here we have used the debouncing delay. Here it will vary, that's what 100 millisecond is being considered, but it will vary depending on the our exact requirement, and we will confirm that key being pressed. So that's why we have confirmed that whether it is still 0, we provide the delay, and then we are still confirming that whether it is still 0 or not. And basically this function will return 1. So here we are returning 1, that means we are saying that key 1 is being pressed. So we need to write this kind of code to detect the different we need to get the values which key is being pressed. So this is simple logic. So same way, let's say if x1 is 0 and y2 is being 0, then we will say that um, key 2 is being pressed, and x1 and y3, then key 3 x1 and y4 means because a is coming in the line of x1, that's why we have a over here. So it is very simple to detect all these keys by using the same logic. So I will not go to the different condition, but you can say that now in the for the next iteration, the x2 will be low, and for the third x3 will be low, and for the fourth iteration x4 will be low, and we will just scan the same y1, y2, y3, and y4. Okay, so at the moment this is the we will finish our the first chapter, and we will start on again the new chapter, the new section.